Hello, everyone, and welcome to our tutorial on data. Can everyone hear me? Just to check if you can hear me, that's great. And if you can't, well, you're not hearing these instructions, so not a lot of help to you. Audio setup wizard. That should help you out. All right, we're going to get going here. Hello, everyone. Welcome to Demystifying the Data. So I am Chris Schott, one of the producers here at KDMC Berkeley. Our programs include workshops on such topics as social media, data visualization, multimedia storytelling, and visual journalism. We also work with companies to develop custom training programs with a focus on meeting the digital needs of your organization. Today's mini tutorial is the second in a series of online trainings we're giving on data visualization best practices, tools, and techniques to help you succeed in the ever-evolving digital landscape. So tell your friends or colleagues to join us again for Design 101 for Data Visualization on March 10th. Before we get started, just a few housekeeping items. We've got all the participants, all you guys, on audio mute because it gets a little chaotic with a bunch of people all talking. But we have a couple ways for you to communicate with us if you need to ask for help or if you have a question. There's a chat box being monitored by Flynn May and Jeremy Lin, our two multimedia specialists. And we also have a question and answer box that you can use for questions about the material you're seeing, which we'll address at the end here. And if we don't get to all your questions, we can answer the rest of them offline. So thank you all for joining us. I want to introduce our presenter here, joining me in the webcam window. This is Peter Aldis, a science reporter with BuzzFeed News and a data visualization instructor for KDMC Berkeley. He also teaches investigative reporting in the science communication program at UC Santa Cruz and has developed online training materials in data visualization for the Academy of Art University in San Francisco. Peter got his start in journalism in 1989 as a reporter for Nature in London, fresh off a PhD in animal behavior. He later worked as a European correspondent for Science, a news editor for the magazine New Scientist, and chief news and feature editor with Nature. His projects include web apps that have appeared, that explore local and global history of climate change and the number of Earth-like planets in our galaxy. So I'm going to turn this over to Peter, and let's get started.
Thanks, Chris. So today we're here to talk about demystifying the data, or finding the narrative, finding the story in data. So as you heard, I'm a journalist, and the question I usually get asked by my editors about stories that are text or stories that are visualizations is, well, what is the story? How do I address that? Well, I'm a journalist. I ask questions. I interview. And that's the same with data as it is with sources. I'm interviewing for their opinions on scientific developments in the news. And I really want to urge you to think about approaching data with that mindset, interviewing the data, starting with questions that you want to ask of the data. So what do I mean by those questions? Well, let's run through a few samples. What of these things we're visualizing is the biggest and the smallest? How has a variable changed over time? What proportion of one thing is this other thing? How is one variable related to another? And in the particular case of maps, where is this thing is pretty crucial. That's why you're putting it on a map. So this is not intended as a comprehensive list of questions, but just to sort of get you into the idea of the questions that I may be asking when I approach a data set. So those of you who were here last week will have already seen this slide, but I do want to bring it up again because these two main flavors of data I'll talk about later on in later slides. So as I said, two main flavors of data: categorical variables. These are descriptive labels given to individual records, assigning them to different groups. Continuous variables are basically the numbers, which can have a range of values on a sliding scale. I'm sure you're all familiar with this already. Okay, let's take a step back and think what we're doing when we visualize data. What we are actually doing is encoding the values in data using visual cues. And here over to the right are some of the cues we can use. We can use the length of lines or bars. We can use slope of a line or the angle between two lines. When it comes to length, that can either be aligned or it cannot. And the aligned one, you'll be able to see, looks pretty much like a bar chart already. We've largely got a chart there. When I say length, we can also be thinking about position, particularly when it's aligned. So if you have points rather than bars, that's a very similar visual encoding relative to a baseline. But there are other possibilities as well. The area of shapes. The volume of shapes, which is actually very difficult to represent in 2 dimensions. I'd suggest you don't try and do it. And then a couple of variants of using color to encode data. So we can use the intensity or the saturation of a color, or we can use the color itself, the hue. Now, here's the important thing. Our brains do not treat those cues equally. And I'm talking here about encoding the values of categorical data in particular. So in the mid-80s, 2 statisticians, William Cleveland and Robert McGill, actually got a bunch of volunteers together and encoded the same data in various ways and measured how accurately they were able to perceive the underlying numbers. This is what they found. You can see pretty clearly that length or position on a line scale is going to be right there at the top. We are very good at comparing those things. Then we move down. Length, if it's not aligned, is not quite so good. Slope and angle, we're starting to get a bit more difficult. Area and color intensity, not so good. I've already pretty much dismissed volume. And then color hue right at the bottom. And of course this makes sense. If we look at those colors, why is there anything that would tell our brains that the blue is a larger number than the green? There's nothing there to give us that cue. That doesn't mean this is something you don't use in visualization. Indeed, as we'll see, we use it a lot, but we don't use it for continuous variables. Color hue, that's good for categorical variables. Okay, so this is really important, this perceptual hierarchy of visual cues, and really think about that whenever you're visualizing, because you want to get up for your main message for continuous variables as near to the top of that as you can. Okay, and here is just a fairly simple demonstration of this. Hardly a chart even, but it's the same data set, the same numbers encoded as the length of bars and the areas of circles. And I think it's pretty easy to see that the differences are easiest to distinguish with the bars. Okay, another question. There's going to be a lot of questions today. And this is the one I'm asked most commonly by people who are thinking about visualizing. Well, what type of chart should I use? My first answer is always, well, you should experiment. You should, with different chart types. You should sketch. You should see which one best liberates the story in your data. But it does help to have a framework. And I'm going to introduce now another question which will help define that framework. Okay, what do you want to show? Pretty central and basic question. And around that, I've ranged 6 possibilities of things that you might want to show from your data. And let's consider them one by one. So let's start with distribution. And this is something, looking at the distribution of a continuous variable, is something that I'd argue you should do to get a sense of the shape of the data before you start deciding how you're going to present your story to your audience. Okay, so here is one type of chart showing what's called a normal distribution. Many variables like height and weight of people tend to be distributed in the same way. The most common values and the average, the mean, is in the middle, right there in the middle there. And then there's a bell-shaped curve if you draw it as a smoothed curve. This tends to be called a density plot that goes to lower, let's say, their weights on the left and higher weights on the right. Okay. There's a few other things going on here. Just to be clear, the x-axis is the values of the variable, the x or horizontal axis. The y-axis or the vertical axis here is the number of individuals, if they're people with a weight, but the number of records in the data at each value. Also on here we have a measure 1, 2, 3, minus 1, minus 2, minus 3, called the standard deviation, which measures the spread of the distribution. But we don't need to worry too much about that. Okay, well, many distributions are not normal. They are highly skewed. This is an example. It's also an example of another type of plot to study the distribution. It's called a histogram. So here, rather than drawing a smooth line, you're making increments in the data. Here, they are increments of $500,000. I'll tell you what the data is in a second, and then you draw a bar for each one. This is my preferred way of looking at distributions. What we are looking at here is salaries of Major League Baseball players at the beginning of the 2013 season. You'll see that the distribution is skewed to the lower end, well, lower in their terms, not in most of ours. The 2 largest columns are both below $1 million, less than $500,000 or less than $1 million. There's very few players over to the right who are paid more than $20 million each year. If you're wondering who that is, way over to the right, it's A-Rod, Alex Rodriguez of the New York Yankees. So that is a distribution that, if you saw that, might affect how you might want to visualize the data. We'll come on to these sorts of questions later. Okay. You may need to look at many distributions all at one go. Here's that baseball salaries data again. And what I've done here is visualized it by team. Now, I could have drawn a histogram for each team, but that's a lot of charts, and they're going to be very difficult to compare. So to get a flavor of how the distributions vary from team to team, I've drawn a chart called a box plot, or a box and whisker plot. What's going on here? Well, the line in the middle of the boxes, the horizontal line, that's the median value. If you put all the salaries in a row for one of the teams, the one in the middle is that value. The range goes from one end of the line to the end of the box or line at the other end. That's the full range of the data with one caveat. And then that's divided into 4 parts called quartiles. The 2 middle quartiles are the box, and the outer quartiles are the line. Anything that the algorithm that draws this thinks is not actually part of the distribution, is an outlier, is drawn as a separate point. Anyway, now I am not suggesting that you want to show your audience a box plot. They're pretty complex plots, and I don't think you really want to show them to your audience, but they can be very useful for getting a quick idea of, in this case, of how the distribution of salaries varies across teams in baseball. And we can see teams like NYA, that's the New York Yankees, LAN, that's the LA Dodgers, and PHI, that's the Philadelphia Phillies, have not only some very high salaries at the top end, but they have a big range as well. The poor old Houston Astros are rather more impoverished by comparison. Okay, moving on. Relationships between one variable and another. Very important when thinking about data and visualizing it. Our standard type of plot here is called a scatter plot. And basically what this is using is that Q of position, which is roughly equivalent to length, on a line scale on 2 axes simultaneously to look at the relation between one variable and the other. Now what we're looking at here is some data illustrating a controversial theory that the level of democracy in a country that it has evolved has been largely influenced over time by its prevalence, historical prevalence of infectious disease. And, well, there does seem to be a correlation here with using this very common visualization. I've also drawn in a trend line calculated using a method called linear regression, and that is the equation of that line. So this is a fairly common form of visualization if you're interested in relationships. The convention here is to put the variable that is suspected to be the causative variable, the explanatory variable, on the x-axis, and the one that's being affected on the y-axis. So these visualizations give a fairly simple and clear message. I do urge great caution with them. Those of you who are data analysts will know this already. Correlation absolutely cannot prove causation, and particularly beware of lurking variables. It so happens that I am not convinced by that story I showed in the previous graph. I think there are all sorts of other reasons why countries may evolve different rates of democracies other than infectious disease. And these are called lurking variables. The classic example, if you look at children in a school with a range of ages, you'll find a very strong correlation between their shoe size and their reading scores, but nobody thinks that having bigger feet makes you a better reader. It's just having bigger feet tends to mean you're older, and older means more experience of reading, and you tend to be a better reader. Lurking variables. So when you're illustrating or visualizing relationships, scatter plots are the way you want to go, and trend lines and so on. But do be wary of suggesting causation when it may very well not be there. Okay. Comparison. This is probably the most frequent thing that I want to show as a journalist. Now, from our perceptual hierarchy of visual cues, we should already realize that, well, you're going to need, if you're comparing the values of variables for different records within the data set, you're going to need a reason not to use bar or column charts. By bars, I mean the horizontal version of this chart. By columns, the vertical version. I don't have strong preferences on which are the best to use, horizontal or vertical. However, when we have a lot of values, I think the bars, the horizontal one, tends to work better. And here's a simple example. This is some data for one of my own stories, illustrating payments by the drug company Pfizer to doctors in California to talk about its drugs. It's actually just payments in the second half of 2009. So you can see that Gerald Michael Sachs, who's a doctor in Santa Monica, California, I think, he was doing rather well in payments from Pfizer for speaking about its drugs. Notice I've highlighted him with some spot color, very simple use of color to highlight one particular person, highlighting part of the story. Okay. Comparisons. Another thing, as well as comparing different things, we won't want to compare the same thing and how it changes over time. This is probably, as a journalist, the most common visualization I do. And I want to show you here that there are various ways of doing that. We can do it with a column chart. The data here we're looking at are the number of recipients of food stamps in millions over the years from 1969 to 2014. So this is the main nutritional assistance program in the United States, and we can see that it's grown. But notice the first two charts. The column chart very much stresses each year as a discrete value. It makes those values very easy to compare. The line chart is encoding the data slightly separately. There's a lot more slope going on here. Yes, you can compare the values for individual years, but it's harder to do. But this chart, the strength of it is it shows you more of the trajectory. We can see when the slope gets steepest, where the most rapid rise in the number of people getting food stamps was. It's much better for doing that. The dot and line chart is a compromise between the two. It's trying to get the best of both worlds. It's using position on a line scale with the position of dots on the y-axis to allow you to compare individual years, but it has the line as well, so you can also get a sense of the slope and the trajectory. The dot and column chart I've just chosen for another example. It's basically like a column chart, but it's a slightly different visual aesthetic. Okay, but I hope you get the sense that choices and chart types change what you're emphasizing in the story here. Okay, what else might you want to show? Composition. By that I mean parts of the whole. This is where the much maligned pie chart has a role. So the data we're looking at here are presidential approval ratings in I think a CBS poll in August last year of President Barack Obama on different policy areas. And I've shown a couple of ways that this data might be encoded, by pie charts and by something called a stacked column chart. Pros and cons of each. One thing I would say here, looking at this, the difference, so the bottom stacked columns, it's probably clearer and easier to see the difference between the approval ratings there than it is in the pie charts, because length is higher up that perceptual hierarchy than angle, which is the encoding in a pie chart. However, looking at this again, I think I could have done a better job with the bottom chart. I could have moved the unsures into the middle and the disapprovals up to the top. Then they would have been in length on a line scale, not just length. And then everything would have been much more easy to read. There's nothing wrong with the pie charts. However, I would urge you this. If you are doing pie charts to illustrate parts of the whole, I'd say don't have more than 3 segments. Get a lot of segments in there and they're just about impossible to read. You want to avoid that. Okay. Another different type of chart. Now here the encoding is area, so we've dropped down the perceptual hierarchy. But this is a particular type of chart called a tree map, which is good for looking at parts of the whole within parts of the whole. So it's a nested composition, if you like. Here is data on the amount of protected land, the total area of protected land in 2012 for different countries and by region. So this chart allows you to compare by area, regions, and countries within those regions. So we've dropped down the hierarchy, but we are doing something very specific, a very specific task for which this visualization is rather good. Okay. Just as we might want to look at comparisons over time, we might want to look at composition over time. This is an example from one of my own stories in the magazine Nature, looking at different types of papers published in a journal called Proceedings of the National Academy of Sciences over time. So it's a stacked area chart again, but notice how the total numbers can change over time. As well as the parts of the whole within them. And just as if you remember, we looked at the difference for simple comparisons over time between columns and between lines, well, there's an equivalent of the line chart for a composition over time, and it's called the stacked area chart. Here's an example that I've made from some US Energy Information Administration data, looking at US gas production up till now and then projected out to 2035. The blue segment of the chart you can see has the label shale gas on it. Well, that's fracking. That's what that is. And we can see how that's what's driving the growth, anticipated growth in US gas production. So this similarly emphasizes the trajectories of the change of the composition more than the discrete values at any one year. Okay, so I'll briefly deal with a couple more potential chart types and a couple more things you might want to show. Connections are very important in this world. If we have any epidemiologists on the line, you'll know that connections are very much part of epidemiology, cases, contacts, and so on. Well, here's a type of chart that shows connections. It's called a network graph. This is another one of my articles from New Scientist magazine, and it's looking at patterns of citation of articles in a very competitive field of stem cell research. So what's going on here? Well, each circle is a scientist in this field, and the arrows are going from one to the other if they've cited them a certain number of times. And the thicker the arrow, the more citations, and the bigger the circle, the more incoming links, incoming citations they have. If any of you know who won, if any of you follow the Nobel Prizes, the big orange circle in the middle is Shinya Yamanaka, who actually, after I wrote this article a couple of years later, won a Nobel Prize for his work on essentially reprogramming adult cells to an embryonic stem cell-like state. Okay. Final thing I want to talk about, location. Well, this is pretty obviously maps. Now, maps are a very common form of visualization. It's very tempting to make a map whenever you have data that can be put on a map, and I love maps. Two main ways of adding data to the location information. One is the area, usually of scaled circles. So what we're looking at here is a map I've made of earthquakes in the United States over the last 50 years, over a certain magnitude. We can see that those earthquakes are predominantly in the West, and we can see that there is one which actually happened in March 1964, which was way, way bigger than the rest up there in Alaska. I've scaled the circles, by the way, by the amount of ground shaking. Okay, so that's one way of encoding data by location and values of the data. Here's another common one. If you have values for different areas, you can use color, intensity of color, to encode different values in that data. That is called a choropleth map, and here I've done it to illustrate GDP per capita as a measure of wealth of different countries in 2013. But I want you to think about the perceptual hierarchy of visual cues again. Area and color intensity, which were the cues I used there, are pretty low down on the on that perceptual hierarchy. And with maps, you're pretty much limited to those. Okay, I've seen slope used, I've seen length used, but it's pretty hard on a map. So ask yourself when you're drawing a map, is it actually the best way to tell the story? If we go back, if I really wanted to show which countries had the highest GDP per capita, would a bar chart be the better way to do that rather than the map? Or maybe both. Maybe the map is just a secondary element. But it is very tempting to make maps. They look pretty, but they're not necessarily the best way to tell the story if location isn't the most important thing you want to show. Okay, I'm going to talk about color because poor use of color, I think, is the most common problem I see in visualizations. And start by talking about the color wheel. Here's a very simple representation of the color wheel. It could have a lot more colors on it. What the color wheel does is it groups together colors that are harmonized well together, and it puts at the opposite side those that have a strong visual contrast. Okay. Now, why is that important? Well, it's important particularly when you have categorical data and you want to develop a color scheme that will help your audience tell those different categorical labels apart. It's called a qualitative color scheme, and examples are on the left. And you can see, if we go back to the color wheel, that what these schemes are doing are trying to spread around the color wheel as far as possible to make them maximally distinctive. Now, if you've got a continuous variable, you're generally going to want a sequential color scheme where the variation in color is intensity, and we will perceive the darker colors to be greater values in the data. Sometimes, however, you may be visualizing change, positive and negative change, for example, in population between censuses. Or you may be looking at, if you're thinking about politics, swing from left to right in an election. And that's when you want a diverging scale. So essentially it's two sequential scales going in opposite directions from each other and cycling through a neutral color in the middle. So that's the general way you want to think about color schemes, but you don't have to invent them for yourself. I strongly recommend this site called Color Brewer. It allows you to enter in the number of classes in your data, whether you want qualitative, sequential, or diverging scheme, and then it will suggest color schemes to you and give you their values in different models of color. RGB, red, green, blue, is the one that's being shown. Originally designed for maps, but not limited to that. You can really rely on these colors, which have been rigorously tested to be maximally informative in all sorts of circumstances, all sorts of charts. Okay, so thinking about using color on a map again, but it needn't just be on a map. One thing you may often need to do, and it will affect the story you tell, is take a continuous variable and essentially turn it into a categorical variable. And this is called binning the data. So here is another version of that GDP per capita map that I showed you earlier, but it's subtly different. The bins are set differently. Here I've set the highest, the bottom value for the highest bin at $40,000. And then I've simply used increments of $10,000 beneath that to set the other 4 bins. And some countries don't have any data, so they're a neutral grey. Now, if I look at this, it tells a story. It certainly says that very few countries are in that highest, have these very high per capita GDP figures. It does a rather poor job, however, at distinguishing down at the bottom pretty much all of sub-Saharan Africa, India, and neighboring countries, most of Southeast Asia, a lot of Southeast Asia end up in these low values at the bottom. Well, the thing is that relatively small differences down at that bottom end of the scale make a big difference, and probably a bigger difference to people's lives than the differences between the countries of Western Europe, most of them, and the United States. So, here's the version I showed you earlier. Here what I've done is I've set the bins so roughly equal numbers of countries are in each bin, and then I've adjusted the boundaries a little bit to make them nice round numbers. This, to me, is a more sensible way of portraying the data. There's definitely a different story in here. We see now that the whole of Western Europe, North America, Australia, Saudi Arabia, South Korea, and Japan are grouped together as wealthy nations. They are what we think of as the wealthy nations. What I think of as the richer middle-income countries are now in the group below that. Russia, Mexico, China, Brazil, some of the North African countries, and so on. And then we have 3 distinctions beneath $10,000. And we can really now see, because people realize that India is a rather different type of place to some of the poorest countries of sub-Saharan Africa. I think this is a more meaningful view of the world and wealth. And this goes back to why the first thing we looked at, distributions, are very important. If you look at the distribution of GDP per capita, it's very much like baseball salaries. There's a lot of countries clustering down the bottom end of the scale. And I would always want to look at the distribution of data before deciding how to bin it. Okay. Talk a little bit about chart furniture. What do I mean by that? Well, it's everything that isn't the visual encoding. Here, the colored bars. So it's the axes, it's the scale on the axes, it's the labels for the axes, it's the title, the subtitle, the source information, the grid lines that make it easier to read. Think about how to deploy it. And also, you can use chart furniture to encode data. Here's that food stamp data again. I've also put in the costs in billions of dollars. But look how I've used grey shading on the chart furniture to show the periods in which the US economy was in recession, which is kind of relevant to the growth of food stamps. Okay. Try and think about how much chart furniture you really need. And often it's not a lot. This is back to that bar chart of payments to doctors again. And notice, I don't actually have axes drawn. I don't really need them. I've done the grid lines as an absence of color rather than lines drawn across the whole chart. There wouldn't have been a lot of extra information if I'd drawn them across the whole chart. A concept to think about here is data ink. If it was actually drawn on paper, how much of the ink is being used to represent the data, and how much of it is there to help support the story, which you want to do, and how much of it isn't needed. And the not needed stuff, you want to get rid of it. Ink, okay, nowadays it's mostly pixels. Data ink, data pixels, same thing. Okay. Now, Labels and annotation, really, really important for highlighting the story in the data. So this is a basic chart. It has the visual encoding of data. We're looking at each dot is a job, and we have the men's median weekly salary for those jobs, and we have women's median weekly salary for those jobs. Fairly clearly there's a relationship between the two. Here I'm not really interested in that relationship. Of course they're correlated, that's not the interesting thing. I'm using a scatter plot here to look at the distribution of these two different measures for women and men simultaneously. But the story in this data is pretty hard to see until I annotate it a little bit. So what have I done? I put in a line of equal pay. I've labeled segments of the chart. Women paid more and men paid more. And in this little version of the chart, I've highlighted the rare jobs for which women are paid more than men. So now we start to see that this is a story about the gender pay gap. It is a different version of it, and I think this is better and more effective. I've really concentrated on the main story here, which is that for the overwhelming number of jobs, women are paid less than men. I've added in another line to highlight a pay gap of 25%. My labels on the chart now say women paid more and women paid less. And I've highlighted the two jobs that are most for which the percentage pay gap is largest. This to me is using some fairly simple labels, annotation, reference lines to bring out a strong story about the gender pay gap. Okay, I've said this once before, I'll say it again. Experiment and sketch with different chart types and see which liberates the story in your data. That may be how you even find the story in the first place. When you think you've got the story, show people, show your colleagues, show your friends, show your family. If they're confused, if they don't get the story, that's a sign you probably need to try again. Okay, so let's just see a couple of examples where I've put all of this together into what I hope is a story. Those of you who are familiar with the website Gapminder or a very famous TED Talk will recognize that this is a recreation of that famous chart. It is looking at a relationship. So I started approaching this data on GDP per capita and life expectancy to look at the relationship between the two. And I expect there to be a relationship. The people in wealthier countries are likely to live longer. Indeed, they seem to. There's something strange going on in the x-axis. You can ask me about that later if you want. But, there's a trend line. But, that's sort of, I could have just done a simple scatter plot, but I've done a few other things. I've highlighted the qualitative, the categorical variable of region using color. I have decided I want to look at how this change over time. So we're only seeing a snapshot here, but this is actually an interactive, and you can use the controls over to the right to animate this data through the years, and all the points in the trend line will move. I have also, while it isn't the main message of this graphic, I've highlighted the biggest countries with the most people by scaling the area of the points by their population. So that's a little bit further down the perceptual hierarchy of visual cues. It's not the main point of my story, but it is useful to tell people which are the biggest countries with the most people. And you can probably work out, if you hovered over the interactive version, you'd see the countries and the data pop up. But you can probably work out which countries are the United States, China, and India by just looking at the graph. Okay, so here's another example. It's tree map. Remember I showed you the tree map earlier. And that was to look at these sort of nested parts of the whole. But here I've added another question. But how has that changed over time? So I've actually made a series of tree maps. They've become rather long and thin, going back every 2 years from 2012 back to 1990. So what we have now here is another visual cue, length on a line scale, which has been used to make that comparison. So now we can see as well, apart from how the area of protected land is divided up between regions and countries at any one point in time, we can see how both the total area and the area for each region has grown over time using length and length on a line scale. This is basically a bar chart of tree maps. So the point I'm making here is if you think about what the data is, if you think about the best ways to represent it, how to use different chart types, how to use different visual cues, how to ask questions and answer them, then you can come up with something that is a relatively sophisticated visualization. There's quite a lot going on here and going on here, but hopefully some stories in the data are being brought out because we've thought about the questions we wanted to ask and the best ways of answering them given the visual cues at our disposal. So I will stop there and we can be open to questions.
All right. Thank you, Peter. So we do have some questions here. I'm going to get there we go. So the first one is someone wanted to know what tools you're using to make these visualizations. What's some of your favorite tools for making maps and graphs?
Indeed. So I think we saw two main tools. Well, I can probably tell you all the ones I use there. Where you were looking at those fairly simple black and gray charts, that was done using R, which is it's both a language for statistical computing, but it allows you to make charts. And there is a package in R called ggplot2, which I used for those. There is also a nice web app, which we can perhaps provide in the links later on, that allows you to use ggplot2. The two examples at the end, the Gapminder-like graph and the bar chart of tree maps, they were both made in Tableau. Tableau Public is the free version of that software, which allows you to save your visualizations to the web. Some of the other ones, I finessed them, were made in R in the first place, and then finessed with a vector graphics editor. So you can use Illustrator. I tend to use Inkscape, which is free and open source. So when I showed you the gender pay gap, that was drawn in R initially, but the annotations I did, the labels and so on, and the highlighting of some of the colors. I think I did put the reference lines on in R in the first place, were basically hand done later on in Inkscape. And when I showed you the food stamps graph that had the recessions highlighted, that was made in a tool called Data Wrapper, which if you just search for that, you'll find it online. And again, that has some interactivity to it. It has tooltip interactivity. It's very easy to use, and it's very good actually for making those time series graphs, particularly if you want to put on some reference lines and bands in your chart furniture.
All right. So another one here. Someone was wondering, what are some approaches to overplotting that you've found to be effective?
I'm not quite sure to what you mean by overplotting. Do we mean putting sort of different layers of data onto a visualization, or perhaps we can clarify that question, or put it, or where you have overlapping points? Is that what's meant?
I think we've got a clarification question coming. But in the meantime, just
Yeah,
another
too
one. Oh
much
yeah, here we go.
data.
So yeah, too much
Yes,
data visualized
absolutely.
at the same time.
So I guess, um, I mean, a very common thing, particularly on maps, but also on scatter plots, um, is just lots and lots of overlapping data. Well, the first thing to say is transparency, is a great help. You'll notice that where I had in any of my charts where I had overlapping points, I'd use some transparency, often in conjunction with putting a border around the edge of each circle if it's a scaled circle, so that it's easier to see the difference. The other thing is, I guess, if you've got too much data to be sensibly visualized, is aggregate and filter. So, if the story comes out from a subset of the data, then filter it. Let's filter down to the data points that are important for the story you need to tell. Or what do I mean by aggregate? Well, you know, if we've got loads and loads of points for different counties or something in the United States, but actually the story is in the difference between regions or between states, for example, we can aggregate the data to a different level, so to the level of region or to the level of state, so that we've got a clearer story. So I guess it's think about the granularity of the data you need to show, and if you do need to show all of the data points and they are essentially getting over the top of each other, transparency can be your friend.
All right, so a few more. Someone just wanted to see the hierarchy of visual cues again, so I'm going to throw that up to take a look at. And then another one, someone was wondering about small multiples, if you can explain what that is and an instance of when it might be useful to use.
Yes, very good question. In the longer version of this talk, which if you come to any of the other sessions, you'll see a much longer version with many more examples. I do talk about small multiples. Small multiples are very, very good. We're on to comparisons. It's another way of showing comparisons, and they're, I think, particularly useful for showing change over time. So if you've got change on a map over time, you can animate a map, but your audience are only going to ever see only ever going to hold one view of that in their visual field at one time. If you look at if you go to the website of the Los Angeles Times and look for their stories on drought, you'll find a rather effective small multiples. And what this is many small versions of the same thing. So it can be a chart, it can be a map. I do think it's rather good for showing change over time. You'll see how they use that very effectively to show the growing area of California under extreme drought as we've moved through 2013, 2014, well, now into 2015, but the time they visualized it, it was 2014. Another thing worth saying is that this type of visualization has become more popular because of the fact that we are largely consuming graphics in the media, certainly, on our phones, on small screens. Now, the great thing is if you've got multiple versions of the same chart showing how something has changed, what's called reflow. So you make them all small, and it doesn't matter what size your screen is, they will go across left to right and down on a larger screen, and if you get to a small enough screen, you'll just scroll down and you'll be able to go all the way through them. That is another reason why small multiples are becoming popular. Not only can they be pretty effective, but they are especially effective when we know that people are using a variety of different screen sizes. If we go back to, if we looked at my Gapminder style plot, that's not going to work very well on a phone. It's going to get very difficult to see and read. And I think that's thinking about the devices that your audience are going to be accessing your visualizations on. It's pretty important and can affect the chart types you will want to use.
All right, well, that was our last question. So thank you, Peter, for the presentation here today. I want to let everyone know that we will have a recording of this available in the next couple weeks for download if you want to go back and review any of this. And we want to invite you to actually join us at some in-person workshops if you're able to. We've got them up on the slide here. UC Davis, March 19th and 20th. Loyola, April 17th to 18th, and we'll have one here at Berkeley as well in the coming time. And you can sign up for those at the link multimedia.journalism.berkeley.edu/CA HealthViz. And we'll also have that link in a closing email we'll get to all of you. Also, our next web training here on Intro to Data Visualization and Design will be actually on Tuesday, March 10th at noon. So join us for that. And thank you all for being here.